name's Ian. I work at Google. I'm a developer advocate on Google+. That is me. I just like talking with a big picture of my face. So what I wanted to talk about today was web services, and particularly whether it's possible to consume them from Erlang, and by web services I of course mean our web services. I hope there's a little bit of principle in here for people that are building web services, some of the things we've learned over about 10 years of doing this, and a bit of practice as well. So if you do want to go and consume any data off of Google Web Service, you've kind of got a hint in the right direction how to do that. So the first thing to point out is that for us, web services are pretty important. For some of our products, it's like that's how they grow. For some of them, that is the product. It's how you actually go ahead and make money, is by calling web services. You know, something like Maps, for example, the integration of that, there's charges against that. That's how you go ahead and make the product make money, which is really awesome. That is a product that targets developers. So web services mean something to us, and they're something a lot of teams want to build internally. If they're building a new product, they want to support it, they want to make a service available so developers can integrate with it. But it's also a challenge, because it takes time to actually go ahead and build these services. Now there's things that can make that easier, but it takes some effort, it takes some implementation. So to try and make it simpler, we invented GData. GData was a standard, still is a standard, it's pretty much dead now, but a standard for representing data for web services. It modeled everything as a collection. It's based on AtomPub, it's extremely restful, it has loads of really nice properties. It was very successful. I think you have the tab up here. These are the APIs that you could call from GData. I think there's like 25 different APIs. There was a couple of billion queries per day going through these APIs. I mean, there's a lot of people using them to do a lot of things. They really worked. The problem with them was that the developer experience was not ideal, and there was a challenge for the development teams within Google. So you'll see here we've got reference guides, client libraries for some of the APIs, but not all of them. Because actually going out and building an API meant, as an engineering team, you had to take on that work to do that. Because internally at Google, we're not making web service calls. We're using protocol buffers. Internally, there's no HTTP being used for that. So if we're extending a web service out, it's something extra the team has to do. And when it's a bit hard, they have to go away and they have to model their project into this GData format. They have to make it fit AtomPub. So that was problematic. That was a disincentive. And then you had to write a client library. If you wanted people to use it, you have to make sure there's a good library. So of course we had a standard library for managing GData, for managing this XML format, but if we wanted to make it really easy to use, we needed a library. That's extra engineering effort. That's extra things for the teams to do. So if you're a team and you're on a harsh deadline, you've got to get your product out, this is the kind of thing that, unless it's core, you won't do. And from our point of view as a wider company, that's not ideal, because we can't make things available to developers. And GData also had problems for users. So there was a wonderful graph of someone's preference on GData. I don't know if anyone in here has used GData, but whether you use it first. But the actual APIs, the actual format itself, because it was so true to AtomPub, was hard to use. It didn't model the domain that well. It didn't model the user's expectations in particular that well. And there were loads of odd edge case type things which turned out to be really common. Like, it's RESTful, so you would get a resource, you would modify it, and you would send it back. But if the resource is really big, that's really painful. We didn't have any way of doing partials. It's very much a thing that is easy to do if you're using a language like Java, which has nice XML support. It's a bit more painful if you're doing it from JavaScript. And of course, in the intervening years, JavaScript has become one of the most important places you're going to consume an API from. So we realized that this kind of bad experience was a problem. And if you're developing web services which you want a wide variety of developers to choose, that is the kind of thing that will come up. You might be developing using Erlang, fantastic. But people consuming it could well be using it from Android or Objective-C and iOS or from JavaScript. Is it as easy to consume there? Is it as easy to work with? And that's one of the things we realized it wasn't. So we thought, well, the problem here was lack of standards. It was too hard to reuse code that had already been written elsewhere. So that's why these things were difficult. It didn't map the domain because we don't using the standards that had emerged for those domains. So some of the APIs, particularly for Google Buzz, back when that was alive, there was a push to make sure we use standards. We went away, we used GeoRSS and Media RSS and Portable Contacts API from OpenSocial, and all this good stuff. And it was great. We obeyed all of the standards in the APIs and made them super easy to get into. But there was a problem. Because just because something had been documented as a spec didn't mean it was actually widely used. And if those things weren't widely used, they weren't easy to actually get involved with. To write a client, you had to go and learn how this spec worked. You had to go and learn how this spec worked as well. And you had to go and learn how this spec worked. And if there was a problem with one of the specs, then it didn't actually connect. It wasn't a case of us going, well, we've implemented the spec right, and the spec is broken. It was, your client doesn't work, your library doesn't work. There's a problem with your API because you cannot do this thing that you should be able to do. So we kind of came back and looked at it again. And we realized that all of the APIs we were building had some standard components. We had resources, and we wanted to operate on those resources. We wanted to do some methods on top of those resources. And we wanted to make that easy for people, both externally and internally. So what we decided to do was build an API service. And the API service would standardize all of the bits. Just like in the previous talk, we have Web Machine, which is providing you with the fundamental basis for doing a RESTful system. You just put the application code into that. I think there's a talk on Web Machine coming up. That's great. That's a really good way of abstracting out the bits that you don't need to be considering for your application. And within Google, we wanted to do that for more and more bits, for login, for authentication, for quota management, for rate limiting, for managing of keys, for managing of which services you had access to. All of these things are standard. All of these things do not need to be repeated from every team. We just needed to work within that structure that we had defined, these methods, these resources. And so we came up with that API service, and we actually released it, I think, a year and a half, couple of years ago, which let us have something like this. So this is the Google APIs page. So now, if you go to a given project, if you want to access a service, if you want to enable access for a service, you just turn it on. You just go in and check the service, and it goes and asks you to accept any terms and conditions. This is all standard behavior. If any API had terms and conditions to accept, we could do them through here. So we can make it very easy for people who want to integrate with us to get in there. And you see, we have 53 APIs now. That's great. That means our internal teams are taking advantage of this, and they're using it because it's straightforward. It's making their life easier to expose their services. So one of the problems, though, is that to make a good developer experience, we still need good client libraries. We still need good ways for people to interact with us. And we don't want to push all that resource back onto the team. I don't want to say, you've made a new product, at Exchange, sell a team. Go and write a client library for it. That's too much work. We've got 53 APIs. How many languages do we support for each one of those APIs? What we want to do is have one client library per language that can talk to all our APIs and take advantage of that. So again, this is the idea that as much as you sit and work out how a user should use your product or should use your website, it's the same idea applied to developers. It's the idea that if someone is developing and interacting with you, then you should think about what their experience will be like. You should think about what their perspective is and what expectations they will have. So we want them to be able to use Google services in a consistent way across the services. And we would want them, ideally, to use a pre-existing client. So if we're going to support a lot of APIs, we need to do it somewhat automatically. So what we did was, using this framework, using this infrastructure, create an API for our APIs. And what that resulted in is something called the discovery service and the discovery document. So this is the discovery document. This is a JSON schema which contains a list of all our APIs. For each one here we have what it is, the description, some information about it, some metadata, and most importantly, a link to the discovery document for that specific API. And this is actually following the JSON schema standard. Each individual service is then documented in the same way. So we get a big document like this that goes through and says what the API is, where you can actually hit it, what's the endpoint. Because we're going through one layer to address all of our internal services, we know what the endpoints are going to be. We know how they're going to be communicated. So we can say, here's the endpoint, here's the path you have to hit, here's the types you might see. So we have a large description of all the different types. This is really important for generating client libraries. In a language, the kind of languages I prefer, languages like Erlang, you have some dynamic typing, so you don't have to worry so much about getting everything right. But if you're working in a strongly typed language, you really need to make sure you've created objects or you've created types that fit all of the structures that you're going to receive. Otherwise, you're going to spend a lot of time converting or building interfaces for that kind of stuff. So by defining all this in a document, we can write generators that can go through that, and we can open source them. And that's exactly what's happened with our client libraries. So each of these documents defines the type, and they also define the resources and the activities. So this is the Google Plus public data API. This goes and retrieves data from things like Elon Plus. And so we have resources like the activities, which is what we call post, we have people, we have comments, things like that. And on each of those you might be able to do a thing. So the method for activities has get. On get, it tells you which the HTTP verb is. It tells you how do you actually go and query this. Are you posting it to put some data in there? Are you getting to retrieve some data? What kind of parameters can be passed? Are those parameters passed on the query string, or are they part of the path? How are the different variables included there? What does the response look like? We refer with the response back to those schemas so we know what type of object to expect. So we have all the information you need to build up a complete call. And what that allows you to build is stuff like the API Explorer. So the API Explorer is kind of exactly what it sounds. It's something that you can click on, you can click through, you can see the different results, and then you can actually try the call out right in the API Explorer. So you can go all the way through and make the call and see what happens without having to write any code. So if you're just trying to work out whether an API does something that you want it to, you can do that without spending any time writing code. Well, you can just try it. If it works, you can bring it into your application. So that's really useful, and we open sourced it to make sure that if people wanted an example of working with this API, it's there. There's a really deep, full example. So the kind of things that, one thing actually I noticed that people had done with this is someone actually built a little discovery checker that pings the API and sees when stuff last changed. So if we ever accidentally leak an API, everyone knows about it, which occasionally happens. And this is just quite a nice tool. All it's doing is just saying, here's what the difference is at each version. So if someone's keeping track of, what new features have you released across a bunch of products they're interested in, they can do that automatically. I think that's a really nice idea. So, I said we had client libraries and these helps us generate client libraries, but each client library needs support. It needs a community that's going to work on it, or it needs an owner inside Google, and ideally both. So, we have these 10 libraries that are our kind of main client libraries. Some of them are very much developed by Googlers. Dart, it's a pretty obvious one, Go, where we have big teams that work on the language itself. Python in this case, because one of the core developers in the API team is a Python developer, and he works on the Python library. Some of the others are much more maintained by the community, where there's people that send patches and contribute from outside Google. But this is still 10 languages out of hundreds, and probably a good 40 or so common languages. This is not everything. And we don't want to be in a situation where if you are an Erlang developer and you want to query it, you can't. So I was looking at this, I actually started looking at this on Monday to see what would it take to query one of our APIs. Is it difficult? Well, the answer is no. Well, obviously, it's pretty straightforward. You can see from there, I'm sure most people can already see it's going to be just sending an HTTP call with some JSON data. This is straightforward. And so I thought, okay, how much further could I go in a day or so? Is it possible to start looking at the Discovery API? And I started playing around with that and found it actually was really pretty straightforward. So where we sort of got to was, I have just some little bits of example of querying through this. And all of the code in here is sort of up on GitHub. And I am far from the world's best Erlang developer. So if anyone looks at the code on GitHub and has suggestions on improvements or structuring, please feel free to send pull requests or let me know. Just leave a comment or raise an issue on it. Because I'd be really happy to sort of explore and understand the best way of talking to some of these APIs in Erlang. And what the whole thing is structured around in this case is really just these using the HTTPC client and Mocky-JSON 2. So because we're dealing with JSON, we needed a JSON decoder. Mocky-JSON 2 seemed like a good one. This means we spend a lot of time pulling stuff out of prop lists, but it works pretty well, and it means we can go away and do all the things that you would need to build an API Explorer like that to go and query the APIs. So if I, here what I've done is just already set up a plus service, the keys for a plus service. So what we have with something like this is I'm just creating a gem server, and I'm storing some state in it about the authentication that we'll need to go and talk to the services. So most Google services, most of the reading part of it, you can get without needing any particular authentication. So if you have a case where you need, just a sec. If you have a case where you just need to go and get some data, you can generally just call a Google service. However, there are rate limits, and if you're not authenticated, you will get hit by those against your IP. So if a lot of people have been making calls on the same IP, you will hit the rate limit, which will be a certain number of queries per day. If you try and do it from a Google office or a Google building like this one, you will definitely hit that limit. So there are two ways of dealing with authentication with our APIs. And one of them is just a simple API key. And all that says is I'm making this call on behalf of someone else. And that's what I'm passing that variable there. And that's really easy. All you do to do that is actually just append the key equals something parameter to the query string. And the other one is OAuth. And we'll look at OAuth in a little bit. OAuth is of course slightly more complicated, but if you're getting any user data, then it's really important to have OAuth in there. So once we've got the service created, we can actually just go in and start doing things like pull out the APIs. So all this is doing is retrieving that document and listing out which APIs are available. Very, very simple code, very simple interaction. Just retrieving the list from JSON, and then we're just looping over the APIs array. All we're getting back is a list of the API entries, and we just in this case need to take the URL and the title out. We can store the rest of it for later use so that we can go back and get it. But the core discovery doc is really just a directory. It doesn't contain a great deal of information. So unless we wanted the icon and wanted some of that information, we would just throw most of that away, just get the URL we'd actually need for the API. And then the API itself, we can just call to retrieve the methods and resources available. So if we bounce into the bit of code here. So the API methods is just a case of retrieving the document, the main document that describes our particular API, which in this case was the plus service. So this was plus.activities.search. Sorry, plus activities. And we are then going to go away, get our document, and pull out all of the methods and the base URL. And the base URL is just the place we're going to actually query. So that's just the root of the service, which if I bounce back up to the top here, you can see is just googleapis.com/plus/v1. All of the APIs are versioned, and we decided to version them in the actual URL rather than using a header parameter or any of the other ways of doing it. Simply because it's more obvious. You look at it, and as a developer, it's immediately obvious to see which version you're hitting. In the same way, it's immediately obvious that this is JSON and how it's structured. Because when we actually return the JSON, we pretty print it by default. You can turn it off, so if you don't want the extra new lines and tabs, you can turn off pretty printing, but by default we leave it on, because it's easier for a developer to see, oh, here's the response I got back, and look at it immediately without having to run it through a formatter. That's the kind of things we've been doing to try and make the developer experience a little more pleasant if you're working with the APIs. So we pull out the base URL, and down the bottom, we pull out, if I can scroll, we pull out all of the methods used as well. So for each of the resources, we're just going to go into that and then iterate over and grab all the methods out and store those as a set of tuples, basically just keyed on the method name. So all we're returning is down here. All we're returning is the method name, or the ID in this case, which would be something like plus.people.get, plus.activities.search, which is just sort of mapping the path, and the actual block of JSON or decoded JSON that represents the method. Because we're going to use that when we make the call to actually construct how our call should look. So if I bounce back to here. Once I've got that, of course, you can do things like listing all the methods that are available, which is just trivial. And I can actually go away and start making a call to the service. So what we're going to do here is call the plus.activities.search service. Let's just clear that from the screen. Plus.activities.search with a query string, which is just for Erlang. So we'll see if anyone's talking about Erlang on Google+. And if I just format that out. Someone's posted about Pistol, and there's someone talking about Erlang Factory, and then something about face recognition and OpenCV. So all this is doing is just querying into the standard API and getting back the JSON response. So the call method function here is not in any way specific to Google+, or to any one of the services. It's using the data contained in the method object to construct what it needs to. We're getting passed in the service, which is just the name of the service we want to talk to, the parameters, which is just basically a list of parameters, the body, which in this case is going to be blank, but if we were doing anything that involved writing, we'd be including that in the actual body of the request. That's going to be some JSON, and then the actual method and the state. So the sort of three areas we have to pull together are the parameters themselves, which could be in the path or could be in the query string. Any headers we need, in this case we're not going to need any because we're using the simple API access, and then just attaching all of that to the URL itself. So the first stage is just get the parameters together, and if you have a look at something like the get path function here, all we're going to do, because I'm lazy, is look at what's in the parameter list that we've been passed in and see if there's any matches for that in the path from the API document. So if there is a parameter which needs to be in the path, it will be something like curly's user ID. So we can just use the regular expression library. A simple replace would have been fine to go in and replace any instances of something like /user ID with the actual user ID value. If they're not in there, we'll tag them on as query string parameters. Now we could be a lot smarter than this because each parameter in the discovery document is actually tagged with is it in the path or is it in the query. But for ease of use, I just loop through the one type. In the same way, we can go through and attach a query parameter for our API key. This is for simple API access. And then we just take any other parameters we've got and fold them into a standard URL string. So that's just going to give us a question mark, key equals value all the way through. If we're making a GET request and we're actually determining what the type of request is by looking at the document, we're not guessing, we're just going to look at what the document says the service wants. We will either give it a GET call, which just sends the URL and the headers, so it's just making a request to a URL with certain headers, or if it's a post, we'll send the URL and the headers, we'll also set the content type and pass whatever body was passed in. So for the real advanced client libraries, we generally have some sort of marshalling that will automatically convert an object or a tuple in an appropriate structure into the JSON that we needed. So that's something you can generate ahead of time because we know what the types are we're going to pass in. So in this case, we're not doing that just because of time, but it's relatively straightforward to go through and look at that kind of data. And finally, we're just going to go away and we're going to make the request and pull our response back. So that's all that we did here, pull together a single URL, it goes away, hits the endpoint, which turns out to be a plus endpoint, and comes back with some JSON, which we just nuke through with just little for each, just a little comprehension here. So that's the basic way of communicating with an API. But we run into a problem if we want to call something like this. In this case, this is to get a user's profile. So this is getting the user's profile on Google+, but this could equally be getting, connecting to your account in Gmail. This could be getting some information about ads you're running. There's a whole range of services this could be talking to, where the type of data we're trying to access is personal. It's attached to a certain user account. As soon as data is attached to a user account, we run into a bit of a problem. We can't use the simple API access. We need to know that a user has actually authenticated you. So we need to implement OAuth. And the new Google services all use OAuth2. So that's similar, pretty much the same spec as is used by, say, Facebook and various other, LinkedIn, and a lot of other services that are offering login these days. And it's very, very simple. There isn't a Erlang OAuth2 client library, but there kind of doesn't need to be. It is an incredibly trivial system to implement. So again, the discovery document could help us, because OAuth2 is based around an ACL of scopes. You have kind of paths which you can do things to. And if you don't, each action will be associated with one or more scopes that a service requires in order to hit it. So as a client, if I want to go away and call plus what people get, I need to have approved access to that scope. And the user can approve or not approve any range of scopes that they want to. So this is what I need to get, and I don't have it yet. Getting it in OAuth2 is, the slight difficulty is you need to send the user off to the OAuth2 provider. Usually that's going to be via a web browser. So if you're doing this as a web service, anything where the user is interacting with it directly, it's not too bad. If you're doing it from a device, it's a little bit more tricky. You generally have to get the user to somewhere where they can get a code and give it back to you. But it is doable. It is doable. So in this case, I'm just going to generate a URL. And that URL is going to redirect me to, in this case, as you see, accounts.google.com. And it happened a bit quickly because I've already authenticated this application. But accounts.google.com has actually redirected me back to localhost 8080. So this has redirected me back to my application. So once I have approved the application, Google, or whoever the authentication provider is, redirects the user back to your app. And in this case, my app is just echoing out the bit of Erlang that I need to chuck in to do a token exchange. So what I get back from this is a code and a bit of state. And the bit of state is just internal for me to verify I am the person that sent that request, so no one can spoof that there has been a OAuth flow. And the other bit is a code. The code I need to send back to the Google authentication service, and then they'll come back to me with a token which I can attach to my requests that will confirm I am who I say I am. So that's what I get there, and then if I make the plus.peopleGet call again, I get a bunch of data. I just chuck that through chuck through another format. You get my name and a link to my profile page. So I can access the personal data. So actually writing those functions is not at all complicated. We have the first one, which is just get auth URL. All that is doing is just sticking some things together. So this is taking the client ID that I specified before when I actually created the object, putting together the redirect URL, so that's telling it where I would like the user to come back to when I'm done. The scope, which is whatever scopes I would like to get access to, and the state, which is this kind of personal parameter that I use just to make sure no one's spoofing. When I actually get that response back, I take the code, I take all of the state which I have internally, and all I do is construct a call to Google. So I have accounts.google.com o/OAuth token. I'm going to pass back the code that I got from the user, my own client ID, my client secret, which only I should know, so this is just going back and forth between me and Google, and again the redirect URL. And if that all matches, I will get sent back the token. So the way you actually would get those kind of codes is straight from the API console. So straight from the same place that you enable the services is where we also let you manage OAuth tokens and everything else. So in this case, this is the one that I was using for this. I have a client ID, which has this, it has my secret, and it has the redirect URLs. So unless this matches, I'll recreate it unless this matches, then then it won't allow usage of this application. One slight thing to note in case you are doing something like this, it is really important to do the state parameter. So I don't actually check it in this function, it actually gets checked where that function is called. Somewhere around. Where is the other bit? Yeah, so there's just a guard on the function, on the handler that handles this, that checks that the state that's been passed in matches the state that's stored here. If you don't validate that that state is, the kind of state that was given to you by the user is the same as the private state, the one you generated, then you do open yourself up to being spoofed. And it is an easy way for someone to break into your application if you're trying to use OAuth to secure it. So just a quick note worth making on that. So that's pretty much it. Like this, there's nothing in this file which is specific to Google Plus or specific to any Google service. All of this will work for all of it. So hopefully you can kind of see how easy it is to consume a service like this, and maybe some ideas for if you're creating services, things that might make a difference. As I said before, that is up on GitHub along with the flow that we just went through there. So please do take a look and file any comments or issues or things that you would like to do better on it. I would love for there to be an actual, top quality Erlang client library. That's certainly not it, but it is maybe the first few examples we can base something on. And that's about it. Thank you. Does anyone have any questions?
Is there any reason why Google needs to open source the
Protocol buffer is open, yeah. Loads of people have implemented other protocol buffers.
It's the serialization format, but not RPC.
Oh, the RPC format? Yeah, I don't think there is. I don't think the RPC format is open. No, you're right. No, I don't know. I don't know. I don't know if it's possible that it's just not that interesting, and is the reason that we haven't implemented it. But Yeah.
Presumably, that was using a service chain. You don't have to do anything else.
Well, a lot of it. So the questions about protocol buffers, which is the serialization format we use internally, and the RPC service that is used to kind of pass those back and forth. And it was, why don't we just release the RPC service, then everyone could just consume those. Well, one of the big problems with that is JavaScript, right? So you cannot just go and create a socket if you're in a web browser. You can pretty much only communicate over HTTP. And that is such a huge proportion of, it really was one of the big things for our APIs is how much of them get used through JavaScript. Because JavaScript isn't just even desktop, it's mobile, web, and a lot of mobile applications are using tools like PhoneGap or Cordova, which actually are running JavaScript in a web browser in a native application. So it's really, really common to have that use case, and it's really important that we support that kind of thing. So even if everyone was grabbing all our services via whatever format tomorrow, I think HTTP would still remain hugely vital, purely because of JavaScript and nothing else. And in general, I think HTTP is the easiest way for most people to get started talking to us. So I think it's an important step, whatever we have. Anyone else? Okay.